Hello and welcome back. In the last video we discussed some typical problems and how to address them in Flutter. I left out one big problem, which is state management, and that's the topic of this video. Well, state management and how to integrate it in a good architecture. If you use Visual Studio to create a new Flutter project, you end up with a typical count application. Here you have a text view and a button to increase the number shown. The magic behind this is to use a state full widget and to call setState to change the state of this widget. Calling setState triggers the framework to run build again and to show the new information on the text field. And that is basically what is state about. Information which might change by interaction, by using the app, or because information changes on the server, and to show the new information to the user. And everything is fine as long as we are in the same widget. So the button and the text field are in the same widget. But we have a problem if more than one widget is interested in the same information in the same state. That's a typical problem, and typical problems are addressed by the design patterns of the Gang of 4. Here we have the observer pattern, which solves exactly this problem. So we have one source of information and many objects, many widgets, which are interested in this information. This pattern belongs to the behavioral patterns. It's also known as event subscriber, publish subscriber, or listener pattern. And this illustration is out of the great book of Head First, the design patterns. If you haven't read it, do so. In Flutter, this observer pattern may be implemented using the inherited widget and change notifier. So if you change something on the object of interest, then you have to call notify listeners to inform all the listeners of this object. If you did the code lab to implement the first Flutter application, you used already a little abstraction of this inherited widget. You used provider. So that's one state management option. And if you search for state management, most likely you will find Flutter bloc. And that was also the first state management I found and told my students they should use it. Besides of its popularity, I was very fond of this illustration. It's following the typical model view model or model view controller, but closer on model view model architecture, which I know from Android development and which I know from C#. So you have your UI, you have states and events, and this block model communicates with the data layer and is called by the UI. But the students didn't like it. Bloc is a great state management library. It's widely used. It forces you to a special architecture and to write lots of code. The tool chain is good, but could be better. It needs Get to have a proper dependency injection. Well, I liked it. The student preferred Riverpod. Riverpod has a couple of advantages. It lives outside of the widget tree. It has dependency injection included. It has a great toolchain, and you have to write less code. So while bloc suggests a strong architecture, Riverpod lets you do what you like to do. And its freedom is nice, but it's also difficult to decide which architecture to follow. In the end, you will have something like a repository. I will explain repository in a minute. Then you will have a state, a controller to change the state and communicate with the repository, and a UI which calls methods of the controller and reads the state to show the information on the screen. MVC, as you might and hopefully know it from any other UI-based application. But we will have a look at the repository. The repository pattern is widely used in mobile applications. It belongs to the data layer, and it's basically an interface for different data sources. Because you might fetch data from the server, store it locally and work for some time with the local data, and then fetch again an update from the server. The other layers are not interested where the data comes from, if it comes from the local database or if it comes from the server. That's one big reason to use the repository pattern. The other reason is better testability. So we have typically 3 layers: the UI layer, the domain layer, and the data layer. Within the UI layer, we have states and controllers. Within the domain layer, we have models, data classes, which are used by the controller and the UI. And in the data layer, we have data transfer objects. They might be the same as in the domain layer, but they might be different. I might need an extra field in my JSON object, which I send to the server. Or in the domain layer, I might add some average calculation field or whatever. So we have models in the domain layer, and we have this data layer with the repository pattern I just described. With Riverpod, we can define state and access this state from anywhere. It's not a global variable, but it is accessible from everywhere. What we need is a so-called ref object to access the state. We will dive into this in the next video. For now, we want to understand that with provider, we have a state or one state object for those 2 widgets and providers, and another state object for other widgets. So we have very simple Flutter code widgets with as less logic as possible. Mostly we have this responsive logic and the interaction with the controller. The state usually is provided as an async value, because in the data layer we have asynchronous communication with the server. So the data layer returns either futures or streams. Streams, or in Android they are called flow. They emit one value after the other, like a stream. Future we discussed in an earlier video. Async value, we have 3 classes extending async value. So we either have async error, if something went wrong, which we can show in the user interface, or we have async loading, we are still waiting for the information, or we have async data. Async data might be a user object with a profile, a name, and my email address, for example, or it might be, as an account example, a simple integer value. So in this part we will use Riverpod, and in this part we will use Riverpod. And as I said, Riverpod provides a great toolchain. Therefore we will start with the count application as it is shown here, and I will explain how everything works with the count application. And then after we will have a look at the typical CRUD operations and communication with the server in the data layer and how to put those things together. See you in the next video. Bye bye.